All right, so now that we have all 45 microstates for a D2 free ion, what we need to do next is group these into different energies. Some of them are going to be degenerate, okay? And so we're going to do that by collecting all the microstates that have the same energy. Microstates with the same energy, remember, are called electronic states. And so when we do this for a free ion, another word for this is determining the free ion terms. All right, so how do we do this? We are going to determine the term symbols, right? These are atomic term symbols now. And so it's 2s plus 1 superscripted L, microstates of the same energy. L, remember, is the maximum value of M sub L for the collection of microstates. So we're going to start with L equals 4. Why? Because that's the largest M sub L on the table, right? 4. So L equals 4. Then for that L value, we're going to look for the maximum M sub S, and we call that S, okay? And so for L equals 4, what's the maximum S? Well, there's no S of 1. That was this boxed out term here. So the maximum M sub S for when L equals 4 is 0. That's what this is. For L equals 4, the maximum and only M sub S value is 0. So S equals 0. Okay? So we would call that free ion term singlet G. Where did that come from? 2s plus 1, S equals 0. 2 times 0 plus 1 is singlet, is 2s plus 2 times 0 plus 1 is 1. G, where does G come from? Remember, it came from that table I showed you on a previous slide when we went over term symbols. Okay, that it goes in the order of the orbitals, kind of what you're used for the orbital names. And remember, beyond F, you just go alphabetically, so G, H, I. So we have L equals 4, so that's going to be a G state. So in total, we have a singlet G state there. So that's the first one we figured out. All right. Now, we have to determine what microstates are embodied in this singlet G free ion term, or this singlet G electronic state. Remember that M sub L ranges from negative L to L. So L equals 4. So singlet G is going to include microstates with M sub L values from negative 4 to 4. M sub S, similarly, can range from negative S to S. Well, S equals 0 here, right? And so singlet G is only going to be from 0 to negative 0, so from 0. So we're looking for microstates with ML values from negative 4 to 4 and MS values of 0. And there, we're going to just choose one from each of these that satisfies these M sub S and M sub L values. And so there's 9 of them, right? We're going from negative 4 to 4 and from 0 to 0 across M sub S. And, you know, you can think about, all right, which ones am I actually removing? It turns out it doesn't matter. As long as you remove the correct number, this is just a bookkeeping analysis at this point. And so, yes, it does, you know, 9 of these have a certain state. And we can think about, you know, what those are, but it doesn't really matter because at this point we're just bookkeeping, okay? So we remove those 9, gone. And what did we get out of that? We got a singlet G state. So that tells us, hey, that singlet G state, it is, it has a degeneracy of 9. There's 9 microstates in there, okay? We still have 36 microstates to go, 45 total, right? Now we go to the next highest M sub L. Next highest M sub L is 3. So next term has L equals 3. Within L equals 3, the highest M sub S is 1. So that means capital S is going to be equals 1. If capital S is equal to 1, 2S plus 1, that gives us a triplet. L equals 3, based on our table, that gives us an F state. So the next term symbol is going to be triplet F. Since L equals 3, triplet F includes microstates with M sub L values of negative 3 to positive 3. And since S is 1, triplet F includes microstates with M sub S values of negative 1 to 1. And so there's going to be 21 of these. And again, which ones? Just cross out one of them or circle one of them. Okay? So I went from negative 3 to 3, and I went from negative 1 to 1 across M sub S, and got rid of those 21. Continue on. Next highest M sub L is 2. And so the next term has L equals 2. For L equals 2, the highest M sub S is that's left is 0, right? We don't have any m sub s of 1 left. So s is going to be equal to 0. So we call this a singlet D. Why a singlet? Because s equals 0. 2 times 0 plus 1 is 1. And then we have D because L equals 2. Remember, go S, P, D. S for 0, P for 1, D for 2. So we're at singlet D. Since L equals 2, singlet D includes microstates with m sub L values going from -2 to 2. And since S is 0, singlet D is going to have microstate values from 0 to -0. So that's only m sub S equals 0. So that's going to be 5 microstates just going across here, keeping m sub S equals 0, but ranging m sub L from -2 to 2. Got rid of those 5. So far we have a singlet G, we have a triplet F, and we've determined singlet D. Let's keep going with the ones we have left. Next highest m sub L is 1. So the next term has L equals 1. For L equals 1, the highest m sub S is 1, so S equals 1. And so our term symbol is going to be triplet P. Why triplet? S equals 1, 2S plus 1, 2 times 1 plus 1 equals 3, and P because L equals 1. Remember, S is 0, L 1 is P. Since L equals 1, triplet P includes microstates with m sub L values of -1 to 1. Okay, so that's fine. And then since S equals 1, triplet P includes microstates from m sub S values of -1 to 1. So these 9, m sub L -1 to 1, and m sub S -1 to 1 are going to go away. Those are going to embody the triplet P, which is going to have a degeneracy of 9. All we're left with is this one lone microstate. It's the highest m sub L on the table is 0, so L equals 0. And for L equals 0, the highest m sub S on the table is 0, so S equals 0. So we have a singlet S state. Remember, when L equals 0, we put an S down, we call it an S state, and our S is equal to 0, our spin is equal to 0. So 2S plus 1, 2 times 0 plus 1 is 1, so we have a singlet S. Since L equals 0, the singlet S state includes microstates with m sub L equals 0, and since S equals 0, singlet S state includes microstates with m sub S equals 0. And so, you know, we just got rid, that's that one state. It's a singly degenerate state. In total, we have 45 microstates. Singlet G, 9 of them. Triplet F, 21 of them. Singlet D, 5 of them. Triplet P, 9 of them. Singlet S, 1 of them. 1 plus 9 is 10, plus 15, plus 5 is 15. 15 plus 21 is 36. 36 plus 9 is 45. So everything is good. So we have 5 different electronic states. So in actuality, just a D2 free ion, we haven't even gotten to octahedral symmetry yet. Just a D2 free ion has 5 different states, and those are going to have different energies. So this is the craziness of electron-electron repulsion. This is only 2 electrons, guys, right? And this is, so we have 5 different electronic states, okay? And so let's stop this video here, and we'll now talk about how to figure out which one of these states is a ground state in the next video.